talking about at the end last time, which was after we looked at um, uh, our paper airplane instructions and the Lego instructions and stuff like that, thinking of instruction manuals as being kind of like computer programs. They're just programs that are executed by walking meat bags rather than by actual machines. Um, what were the kind of types of expressions that we had? Okay, so you guys had declarative or imperative expressions, which were like do this, fold this thing here, put this piece there, let this variable have some value, do some sort of mathematical operation. Okay, um, and those, well, okay, can be just kind of whatever. And then we didn't necessarily use this tons in the paper airplane folding, but we definitely saw this in the Lego set, right? Build three of this thing, or repeat this set of instructions some number of times. Or while the number of hungry students is positive, keep making tacos until there are no more hungry students. Okay, so some sort of process that's going to be repeating possibly a specific number of times and possibly an unknown number of times until some condition is either no longer satisfied or is satisfied. Um, and then we have conditional expressions that always are going to start with the word if, and whether or not you do something is going to be determined by whether or not some logical thing is true or not true. Okay, and then we'll also talk about functions. So the declarative stuff is pretty straightforward. It's just do stuff. So what we'll kind of hit today are the conditionals and the iterative expressions. And I'm actually going to start with the conditionals before the iterative, even though we kind of put them in the other order for the sake of the paper airplane stuff. Okay, make sense? All right. So um, I'm going to, let me start a new file here. Okay, I'm going to program in Python. Um, the fact that I'm programming in Python is not quite so important because one of the things that I like about Python is that if you didn't know that you were looking at Python code, it would look like it's just English, right? And you'd be able to read it and pretty much figure out for simple stuff exactly what it means. Okay, so for example, if I just want to have a declarative or imperative expression like print something like this, then if you saw that, what do you think is going to happen? Yeah, I would hope that it's going to print hello world. Um, oops. And sure enough, it does exactly that. Okay, so no big deal there. Um, but let's talk about conditional expressions. Okay, um, so every language, by the way, you see how I put a little hashtag in front of that line? Um, that makes that line of code a comment, which means it's just a note to self kind of thing. It doesn't actually get executed. Every programming language has some way to do commenting in it. In Python, you put a hashtag in front. In other languages, it's some other character. But yes, you can use that to basically like it's like putting sticky notes on something, just for notes to yourself. Okay, so a conditional expression, we need a Boolean expression, and a Boolean expression is something that evaluates to either being true or false. Okay, so is like for example, we had the if the number of hungry students is greater than zero, then order a pizza, right? So the number of hungry students, that either is greater than zero or it isn't greater than zero. There's no other option. Yes? Okay, so things like that are Boolean expressions. They're things that can be true or false, and that's it. Okay? Often these are somewhat mathematical, so like the value of a number being equal to something or not equal or greater than or less than or something along those lines. It doesn't have to be, but it's often something along those lines. So I could say something, for example, like if um, something like this. Okay. Now, if I try and run this, it's not going to work. And any guesses why? Yeah, I've never defined what num students is. Okay, so let me do that. And I'm just going to pick 5 for sake of demonstration. Okay, so what's going to happen? Let me just type some more stuff here. Okay, so what's going to happen in this instance? So what did I set num students to be? 5. Is 5 greater than 0? Yes. So we should print someone is hungry. What will also print? Well, okay, the hello world. So yeah, let me just delete that because we don't need it anymore. Um, so the question is, will the statement "I like tacos" also print? And it will. Okay, and in fact, let me just demonstrate this, and then I'll explain why. Okay, so what do you notice about what's the difference between printing "someone is hungry" and printing "I like tacos"? It's not indented, right? So you guys see how the "someone is hungry" is indented, whereas the other one is not? That's how you tell what is sort of going to be executed if the condition is true. It's all purely based on indentation. Okay, now let me show you why Python did it that way. So let me go to another program. Okay, so this is something written in C from my other class. Okay, and you see how it has these curly braces? So, what is executed if the condition is true? You have to put that inside a matching pair of curly braces, a left curly brace to open and a right curly brace to close. Okay. Um, and then, but you don't have to tab over. The curly braces determine purely the structure. So what? Okay, so this is in C. C is a language that's existed since the 70s, and it's not as if it came out of nowhere, right? It was inspired and built on other earlier languages, but it's a pretty old one, right? So 50 years basically. Um, the curly braces are the only thing that tell you the logical structure, but most C programmers also indent because it makes it easier to read and kind of visually see the logical structure. Okay, so when the guy who came up with Python, his name's Guido von Rossum, he looked at this and thought, you know, the C programmers, like everybody always indents. And so why don't we just dispense with the curly braces and make this purely about indentation? Right? Makes it easier to read. And the other thing is, guess what you will be tortured by if you are programming in C and you try and program at 2 in the morning? You will never find the missing curly brace, right? And if you're off and there's not a matching set, then it doesn't work, right? So good luck finding it at 2 in the morning. So hence, Guido made it that indentation purely determines what is sort of the body of the conditional statement. Okay, and when I say body, I mean what happens if the number of students is greater than 0? What do I want to have happen if that condition is true? In this case, I want to print something. I could do like 15 different things, but How do I know what will get executed if that's the case? The indentation. That's purely it. No curly braces or anything. And then the I like tacos is going to execute regardless of what happens with the num students part. It's not indented. Okay. And I could also nest these. So for example, I could do something like this. Okay, something like that. So um, so I could nest these as much as I want, and each time I'm nesting, I tab over one level. Okay, does that kind of make sense? So what's going to happen now? Yeah. So the number of students is greater than 0. It's also greater than 3. But what about if I change this to being something like, say, greater than 7? Then why does why does someone is hungry print but not the other one? Right, and 5 is bigger than 0, but definitely not bigger than 7, right? Okay. Now you want to be careful on nesting them like that because you could end up in like your world's worst nightmare logic problem. Okay, but you can do it. Whether or not it's a good idea is a separate matter. Okay. Um, Now, the other thing that we can do with these if statements is I could do, so oftentimes we have structures where we want to do something like this. Okay, where if a condition is true, we want to do one thing, and otherwise we want to do something else. Okay, so when I run this, exactly one statement will print. Either someone is hungry or nobody is hungry. Both of those will never print. And always one of the two will print. And what determines that is, well, the Boolean condition, right? Because the true is going to be this case, and the false is going to be that case. And it can't both be true and false, right? That doesn't work. Okay, so if I run this, what should happen? We get someone is hungry because num students was 5 and 5 is bigger than 0. It's not less than or equal to 0. Yes? Okay. Now, I can also do one other thing, which is I could say this. Okay. Actually, no, I can't do that. Let me just say greater than 1 there. Okay, so if there's more than, well, here, let me say it this way. That the number of students is greater than 1, that means that there's at least 2, right? Because students come in integers that are hungry. But maybe there's exactly one student that's hungry, and I want to have sort of multiple conditions here. So I can do that with ELIF, which is short for ELIF is short for else if. Okay? Just shorthand. Okay, so what should happen in this particular case? What's going to print? What do you think? Several students are hungry, okay, or dudes. Why did that happen? Yeah, because there's right now we set num students to be 5. 5's bigger than 1, okay, so this is going to execute. And then this thing here, well, let me change num students to 1. What's going to print now? Exactly, one dude is hungry. Okay. Now, yes, okay, I was just about to get to that, so thank you. So, why do I have one equal sign there, but two equal signs down a couple lines? Okay, so what's the difference? Yeah, okay, so the difference is structural. What am I doing when I say num students equals 1? I'm saying, okay, I have a variable called num students, and I want to set its value to be the number 1. Okay, I'm assigning the value of something. And when I do so, I use single equals. But what am I doing here in my conditional statement? I'm checking, is it the case that the number of students is equal to 1? I'm asking a question. Okay, so in that case, and this is true in most but not all languages, when you're checking whether or not some two things are equal, you use the double equal symbol. When you're assigning the value of a thing, you use the single equal symbol. Okay, so that's the difference. Does that make sense? Okay, but let's think about why it has to be like that. Well, it doesn't have to be like that, but why is it like that in most computer programming languages? Is it like that in math class? Do we ever use double equals in math? We never have to, okay? We use equals, but we use equals to mean both things, right? Because we do stuff like we say let x equal 5, but then we also say if x is greater than 0 or if x equals 0, then blah, 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 right? But we only ever write single equals and we do that. So how do you know the difference between assigning variable or checking whether or not two things are equal in math class if we use the same symbol for both cases? How do you as humans know? It's something, huh? You infer it from the context, right? And you guys are not morons, I would hope, right? So you understand that there is a context to stuff. Yes? What does a computer not understand? Context. And as such, we need to have a different set of symbols for the two meanings of equal. And the thing that's sort of stuck, I don't know who came up with it, is to use single equals and double equals. Okay. It's not the only way you could have theoretically done it, but that's the way somebody thought up, and it makes sense to me. Okay, so we stick with it. Okay, so does that make sense, the difference between equal and double equal? Lots of languages have that. C, C++, Java, Python. I'm pretty sure Rust has it that way, right? So lots of languages do it that way. Not the only way, but lots do it. Okay. Um, okay. Good. So, um, so here we have conditional expressions, right? And what's the fundamental thing? They all have to have a Boolean condition, something that can either be true or false. Now, in this case, let's make a new one, just as for sake of demonstration. And I'm going to delete the I like tacos. We don't need that anymore. Okay, so a Boolean expression, that's a thing that can either be true or false. Can I combine Boolean expressions in interesting ways? Okay, and so when I say combining, what kind of words come to mind? Okay, and what else? Or, not, XOR, right? Any of the logical operations that we can do, right? So it could be the case that I want to have a conditional expression that depends on two things being true. Okay, for example, I could say something like if, what about if I want to know if the number of hungry students is between 2 and 10? And I'm just making up those numbers for sake of demonstration, right? Perfectly reasonable question, right? And in math, how would we write this? Yeah, so in math, I might say something like 2 less than or equal to num students less than or equal to 10, something along those lines. Okay. But I can't write it that way in programming. What I have to say is num students greater than or equal to 2 and num students less than or equal to 10. Okay. And what I like about Python is that what do I put if I want to do the logical anding of two things? I put the word and. Well, that's certainly easy, right? You look at this and you're like, oh, well, I know exactly what this means. Okay, that's not the case in other languages. So, for example, in C, instead of and, I would have put two ampersand symbols, and or I would put two vertical bars. Once you know it, you know it. But if I just handed that to you and you looked at it, you'd be like, I don't know what this means. Whereas if I handed you this, would it be pretty clear to you that I mean and? Yeah. Okay. All right. So what else? I also have to have a colon here. That's kind of a picky thing. And what do I want to do if the number of students is in this range? I don't know. Let's just print something. Right. I'm just making it up at this point, right? But there. Okay. So will this execute? Will we print nice? What was our num students? I set it to 1. So is this logical condition true? No. Okay. So it won't print. And I could also do something like this. Will it execute then? Why not? It's greater than 2, but the second condition is not true. It's not less than 10. Okay. So in this case, it won't run. Okay. But what about if I change this to or? Will it run now? Yes, because is it the case that the number of students is greater than 2? Is it less than 10? No, but the first condition was satisfied, and that's enough for or. Okay, so when you construct the statement here as to what the condition is, you have to basically use your head and think, well, what do I need? And is or and or not or any of the other ones? What's logical to pick? And that depends on what your program is supposed to do. Okay. Um, okay. So does that kind of make sense? Yeah. All right. So let's look now at looping structures. And the reason I did the iterative ones first, so let me actually start a new file here just for cleanliness. And we'll call this loops2. Okay, there are 3 sort of categories of loops. And they're these. Python only has 2 of the 3. Now, what the difference is between while and do while, I'll explain in a moment. But let me start with an example of a while loop. Okay, so let's say that I have a number of beers. Okay. Um, oops. All right, so I start with 10 beers. It's going to be a great night, right? And while I still have some beers, well, crack one open. If I run this, what's going to happen? It won't crash, but what will happen? Yeah, it's going to print crack one open basically forever. Why? Because I never. So what happens when a loop executes is first I check the condition. Is the number of beers greater than 0? Yes or no? If so, I run everything that's indented one line, which in this case is just a print statement. Once I finish the printing, I go back up and I check, is the number of beers greater than 0? Yes or no? And then execute the loop body. So it loops. That's why we call it that. So why is this looping indefinitely? What have I not done with the number of beers? I never took one away, right? If I crack one open, then I really should do something like this, which is subtract 1 from the number of beers. Okay? Now, what should happen? What do you guys think? It's going to print how many times? 10. Okay. Why 10? Because that's what I started with my number of beers. And what did I do each time I cracked one open? I subtracted 1 from the number of beers. Okay. And what was my condition? That I'm going to continue doing this until the number of beers is no longer greater than 0. Okay. All right. So this is why I started with the conditional expressions, because loops always are built with a conditional expression, right? There's got to be some Boolean expression or something that tells me, do I continue looping or not? Okay. And when the loop finishes, so let me go to here. And I could actually put in the smiley face emoji if we wanted to. We could do that, right? So when did the no more beer get printed? After the loop finishes executing, which in this case it did it 10 times, just only because I set the number of beers to be 10. Just pull that number out of thin air. Okay. So the condition is determining whether or not we start and therefore continue looping. And it could be the case that the loop runs no times. So for example, let's say that I changed it to this. Is it going to print? What's going to happen? Okay. Why did that happen? Well, because what was num beers initially? And is 10 greater than 20? Nope. So I never started looping in the first place and just moved right on to the next instruction. Okay. Does that make sense? All right. So that's a while loop. Okay. And the difference between a while loop and a do while loop is where the condition gets checked. So here, when did I check the condition as to whether or not the number of beers is greater than 0? Before I did anything. Okay. A do while loop, you do the loop body and then you check the condition. So the condition's sort of at the other end of it. Python doesn't have that as a primitive form. C does. Other languages do. And so anyway, because there isn't one in Python, I'll just kind of ignore it. Okay, the last or the other kind of loop that's a pretty common one is the for loop. And in Python, it looks something like this. Okay, so for I in range 0 to 6, print I. So what do you think is going to get printed? Nothing? Oh, 1, 2, 3, 4, 5. Okay, so let's think about why that happened. And also why perhaps you're very irritated about something. Okay, so for I in range 0 to 6, did I end up printing 0? Yes. Did I end up printing 6? No. This is one of the things that just drives me bonkers about Python. 0 is included, but 6 isn't. So in terms of like mathematical notation, it's kind of like that, like in calculus or something where you have the idea of the square bracket versus the round parenthesis, right? 0 is included, but 6 isn't. Now, here's why I think Guido did it that way. How many things printed? 6, 0 through 5. Okay, I think that's why he did it this way. But if I were designing Python, I would have done it 0 to 5, or had 6 be included. But I didn't create the language, so sorry. Okay, and here I started counting at 0. Did I have to start at 0? No, certainly not. But it's often the case that we do so in computing. We start at 0 and not 1. That's just kind of typical. Okay, good. So what else could I change here? I mean, I can obviously tweak the numbers 0 and 6. Any other thoughts about what I could do? Or questions? Yeah? Okay, good question. So here I used I as a counting variable. I picked the letter I because typically we just use that letter for counting variables. So, like, if you think about in math class, right, you often use like X, Y, and Z to be variables. If I wrote alpha on the board, what would you assume alpha represented? Probably, like if I wrote a lowercase alpha on the board and I'm in math class, you might be like, I bet you alpha is an angle of some sort, right? Because we typically use the Greek letters for angles, we use X, Y, and Z for variables. If I wrote M on the board, what would you guess that I was? Uh, something slope, right? If I wrote F, what would you guess was about to happen? Some sort of function, right? So we use certain letters. We don't have to use those letters, but we just kind of often do out of habit. And for counting variables, I, J, K are usually the ones that we pick. We don't have to, but we certainly do quite often. Okay, so that's why I picked I here. It certainly didn't have to be I, but again, it's just habit. Now, the other thing that did I ever explicitly say what to do with the number I each time the loop got executed? So what is the default for a for loop if I don't specify otherwise? It adds 1 each time. Okay, so I started with 0, and then it became 1, 2, and so on. Okay, so if you don't specify with a for loop in Python, the assumption is that you're just adding 1 each time. Okay, does that seem like a reasonable assumption? Yeah, and that's why the language is written this way, because often you're counting, you know, through a number of discrete things. Do I have to count by ones, though? Could I count by twos, for example? Now, why might that be a good thing is another matter, but could I at least theoretically do so? Sure, right? And in Python, the way to specify that is just this, right? So I'm counting from 0 to 6 by twos instead of by ones. And this time what happens? Only the even numbers print. Okay. Um, Now, that begs the question, why might I want to skip by twos? I mean, other than for just demonstration's sake, any ideas why that might be useful? And try and think of like a non-contrived example. Okay, I'll give you a good one. How many of you guys have seen the SpongeBob meme where he's got like this beak on his thing and he's like clucking around like he's a chicken or something? Yeah. And how is the text in memes that use that image? Yeah, it's a mix of upper and lowercase, and it looks ridiculous, right? Okay, and so that meme and that method of writing text has gotten appropriated. Okay, so let's say, for example, that President Biden's Twitter account, they post, we're going to devote $50 billion to fix the water in Flint, Michigan. Okay, and what is some jackass going to reply on that post? Well, that, or, but how are we going to pay for that? Right? And it's going to be in that alternating lowercase and uppercase. And what does that lowercase and uppercase usually signify? Some sort of like sarcasm or whatever, right? Um, yeah, okay. So let's say that you wanted to write a program that took in a string of text and did that alternating upper and lower case stuff. Well, this would be a fantastic reason to count by twos. Okay, because you could say, all right, I'm going to do 0 to 6, do all the even ones in uppercase and all the other ones in lowercase, and then I'll have a string that's kind of SpongeBobified, right? I mean, yes, that is a silly example because, but yeah, okay. Does that kind of make sense? Yeah. Okay, so we can count by twos, we can count by whatever we want. We can go in reverse order. So, for example, um, there's no reason I have to start at 0. And so let's say I wanted to start at 6 and end at 0. What should I put here if I want to count backwards? -1, right. And then it counts down instead of counting up. Maybe you want to count down. For our beer example, right? That might actually make more sense. You know, if I wanted to write a program that did the whole like, and actually, I just my other class they have to do this. A program that does like 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, and then so on, right? Um, yeah, so you can count up, you can count down. It's up to you. Okay. And in fact, let me change this back to counting up. I could have a variable for the top number. Okay, so in this case, do I know what num beers is? We do because we defined it earlier in the program. Okay, but let's say that I didn't actually know what the number of beers was. This program would still run. In this case, it printed it 10 times, but maybe I don't know what that number of beers is. Okay, so a good example of a situation where you'd be is, let's go back to the SpongeBob example. Let's say that I ask the user to type in a bunch of text, and then I want to see how many characters or how many letters did that person type. Well, then I just need to count through until I hit the end of the thing. And there's a way to know when you've hit the end of a user typed in stuff, which that's technical. I don't want to talk about it. But point being, you might not know in advance how many things you're going to be counting through. Okay. Um, all right. So does that kind of make sense? Yeah. Um, okay. So let's see. What else do I want to do? I think. Oh, another thing about using I. Okay. This may seem slimy to you guys, but let me just type in another one. Okay, and again, 5, I'm just picking kind of at random here. Okay, what printed? The numbers 1 through or 0 through 9, followed by how many times did howdy get printed? 5. Okay, I've used I in both cases. Does that feel bad? Because I've kind of used I in two different ways. You can get away with that. And this is one reason why we typically use I, J, and so on as our counting variables. Would it be a good thing if I used num beers in two different ways? No, that would be horrible. But counting variables, like, do I care what I is after this loop has run? No, it's sort of a disposable quantity. And so we can reuse it, that same letter again and again without basically without messing things up. Okay, so um, yeah, so if you've got like a really big program, then yeah. Now I could, for example, mix these. So let me do something like this. I can't have nested loops. I can do something like this. This is fun. Oops, what did I mess up there? Oh, I've got it indented. Sorry. Forgot the indentation. There we go. Oops. There we go. Okay, so now what printed? Whole bunch of stuff. A total of 100 things got printed. So what did I do first? I printed I comma j. So what do I see in my printing? What's the first thing? I comma j, and j is in the inner loop. So what's going to happen is j will count up by 1 each time, but I is still 0. So I'll get all of the 10 instances. Well, here, let me change the number so it's not so big. That way it's easier to see. Let's just do 4. Okay, so what got printed? Well, j counts from 0 to 3. I stays at 0. Then what happens to j? It resets to 0, but now what's I? And so on. Okay, so I can have nested loops here. How many times did the inner loop run? 4 times. Well, actually 16 times, right? Why 16? How many times did the outer loop run? And for each of those 4, how many times did the inner loop run? Also 4. And what's 4 times 4? 16. Okay. Okay. I think that's pretty much where I wanted to get today. So, any questions, preguntas, or fragens? No? Yes. Mm, not quite. So keep. Yes, but I would have to use a function to do that, which we'll talk about, I think, next week, right? So in this case, like actually, you could think of the print function. It is a function, right? So the print only happens when I call this function, um, and yeah, yeah. Maybe when we talk about functions, that'll be a little bit more. I think I see where you're going, but I'm not entirely sure. Oh, all right. Anything else? No? How about we quit early? Because it's Friday. So, all right. See you guys later. Have a good weekend.